Okay, I'm going to do a couple horizontal projectile problems for you to use as review. And the first thing I have here is just a conceptual comment that we need to understand the horizontal velocity, which we just call v sub x, is constant, and the vertical velocity increases by 10 meters per second downward, so in the negative direction. So we can start with an example. So the example we'll start with is a ball thrown horizontally at 20 meters per second and lands 3 seconds later. So I'm going to start by drawing a diagram of what's going on. We have something thrown horizontally. So v sub x is 20 meters per second. It's going to go out and down, and we know that it lands 3 seconds later. The question is going to be, what's the vertical distance and what's the horizontal distance? So we're being asked to find the vertical distance, d sub y. In other words, we're being asked to find how tall is the cliff and how far out does it go, d sub x. Because we know time, this problem is going to be easier than if we didn't have time, because we can use graphs to calculate stuff about the motion. So I'm going to start with the horizontal motion. So I have v sub x is 20. Starts out going 20 meters per second for a total of 3 seconds. And so then the area of a horizontal velocity versus time graph will tell me the horizontal distance that it travels. So I see that d sub x is equal to the horizontal speed times time. I'm going 20 meters per second for 3 seconds. That should make sense that we end up going 60 meters horizontally. That's our horizontal distance. If I want to figure out the vertical distance, I look at the vertical velocity versus time graph. So here I see that v sub y is going to start at 0 because it's a horizontal projectile, so there is no vertical velocity at time 0. It steadily speeds up in the negative direction as it falls down for 3 seconds. So if I know that it's falling for 3 seconds and it speeds up at a rate of 10 meters per second, then at 3 seconds it's going to be going negative 30 meters per second as it falls towards the ground. So the area of this graph is going to tell me my vertical distance, dy. So dy in this case is the area of that triangle, which is 1/2 base times height. The base being the 3 seconds. The height being the final speed, which is 30 meters per second. So 3 times 30 is 90 divided by 2. Gives me 45 meters. That's how far down the projectile falls. So the note that I want to make here is that with time, if you're given time in the problem, use graphs. You don't have to use graphs, but it's the most straightforward way to find or to visualize what's happening, graphing what's happening, and getting all the information that you need. Okay, we'll do another example now where we don't know how much time it spends in the air. Okay, the next example I have here, a ball is thrown horizontally off an 80-meter tall cliff at a speed of 12 meters per second. I want to ask then, how far out does it go? So I want to know the horizontal distance from the base of the cliff. So again, I'm going to start with a nice clear diagram, label everything on the diagram that I know. I know that it's thrown with an initial speed of 12 meters per second. It's going to go out and down. I don't know how much time it takes to land, but I do know that the cliff is 80 meters tall. So that's my dy. That's my vertical distance. And then the question is asking, what is dx? How far out does it go? So here, without time, I need to use the height of the cliff to determine how long it takes to land. Which should make sense. The height of the cliff is going to determine how much time it takes you to land on the ground below. You jump off a taller cliff, it's going to take more time to land. So how do I use the height of the cliff to determine the time? I need to use my equation, dy equals 1/2 gt squared. I know the height of the cliff, dy, is 80 meters. G is acceleration due to gravity. It's 10 meters per second times t squared. So if I go through all the algebra here, 1/2 of 10 is 5 times t squared. To get t, I need to move the 5, divide both sides by 5. 80 divided by 5 is 16. 16 equals t squared. Take the square root of both sides, and I get that 4 seconds equals the time in the air. Now that's not what the question was. The question wanted to ask, how far out horizontally does it go? Well, I know that it's traveling at a speed of 12 meters per second, so I need to know how many seconds it spent traveling at that speed. Now I know that time is 4 seconds, so I can go ahead and solve the next part of the problem to get dx. dx equals vx times t. I'm going a constant 12 meters per second for 4 seconds, meaning we've traveled 48 meters. So there's two things that we've done here. The first example, if I scroll back up, the first example, we were given time. And with the time in the air, we could figure out everything else using graphs, because once we know the t for the graphs, we can fill in all the other blanks. The next example we did, we knew the height of the cliff. With the height of the cliff, we could figure out the time it spent in the air. Once I knew the time it spent in the air, I could figure out how far it went out. Okay, so hopefully these are helpful. You can go back through, change the numbers. The process is the same regardless of what the numbers are in the problem. Okay, so hopefully this was helpful.